my two guests today are Chuck Adomanis and Loren Schreiber. Chuck is from Hudson Scenic. Loren is recently retired from one of those San Diego universities. And we're going to be talking about deck winches and tracks, how to move them, and how to get power and control to them. So, gentlemen, I'm going to turn it over to you. You can arm wrestle to see who wants to go first. And away we go.
Well, how about I just start real quick here and define the scope of what we're talking about. So the only reason you have deck winches and deck tracks and so on is because you're trying to haul some kind of freight. And those fall into some fairly easily categorized forms, starting with skids, which in my definition of a skid is nothing more than a piece of plywood with carpet on the bottom. It's attached to the cable and drags back and forth. It's to move small pieces of scenery. And yeah, so then there's pallets, which would be like the next step up, which would be a small, very low platform using the smallest wheels you can get under it for hauling things that are maybe a little bit heavier. Then you have wagons, which would be just a platform of various sizes that have typical casters underneath them. Turtles, which we define as a platform that can rotate and translate simultaneously. And then slip stages, where you've got an entire set replacing another set. You see it often in opera, where they just roll one set off and they'll bring another set on these slip stages. So, and I got my outline up here. And probably the most typical way to drive these units that we found in theater, and I don't know really how it's what they're doing on Broadway these days. I haven't been there for a while, but most of the theaters I've had experience with across the country are using wire rope winches to drive these various units across the stage. And one thing we need to define is that the difference between a deck winch and the winch you might use for hoisting scenery over people's heads, the design is completely different, really. Certainly the hoists are going to have greater safety devices on them, load brakes that you don't normally find in a deck winch.
Oh, do we lose Loren?
Fortunately, we lost Loren again.
All right. Well, I can pick up and for a little bit until we get him back. I think no question where Loren was going was, these different types of winches that are sort of common in the industry. Deck winches, sort of specific to what I think we define normally as horizontal or non-gravity loads. Don't need to have quite the sort of levels of safety and redundancy that we'd expect in a overhead lifting kind of machine. But I think to go back to his earlier point, in terms of things that are being used now, I would say 90%, if not even higher than 90% of sort of the applications we see certainly on Broadway shows is going to be a pretty conventional cable drum winch. And maybe I'll just try to throw up what at least our version of that is as a sort of starting point. I think if people can see my screen, but I would say this is a Hudson image I have up here. I think many people are similar, where we have sort of basic, some kind of gear motor power package. Typically these days that is typically either sort of a standard AC induction gear motor. Some vendors will do that with servo motors, if that's where they've done. Certainly in the past, you would have seen that be a DC motor. back probably when Loren had started in the 80s and even continuing until I started at Hudson, DC motors were pretty prevalent, and that was mostly about speed control. And I think we'll come back to that in a minute. But nowadays you see a lot of sort of typical AC gear motor type stuff. There's usually some second stage, most often that's done with chain, I think, but you sometimes see that with belt or other things to couple the output of that gear motor to the shaft that is actually turning the drum. We do that with roller chain, like I said, and we often in that use what people refer to as a slip clutch or a pull clutch, some sort of device that, if desired, allows you to decouple that drum from the sort of drive system. And historically, I'd say the rationale there was that if you looked at failure possibilities, it was all the stuff upstream of this machine, the electronics, the controls, the PCs operating them, that were the things that everybody was worried about failing. And so there was always a desire to be able to sort of quickly disconnect the load, i.e. the drum and the cable and the pallet it was connected to, from this motor package, so that you could put a crank on the end of that shaft and move it mechanically the old-fashioned way. We still have that detail in our winches. I know several other people that have that detail in their winches. I can't tell you the last time I heard somebody use that function, because the controls have caught up with the robustness of all the mechanical parts. But it's there, and I think it makes sense in these applications. Again, as Loren was pointing out before, I think in any sort of overhead hauling application, this design detail of the chain and the clutch and all those and the pull pins is a totally out of the question kind of thing. But for deck winches doing horizontal loads, seems like a good choice. And then I think the key to these machines for everybody is the fact that we're using typically a grooved cable drum. So that is a helically grooved, i.e. the equivalent of a bolt style thing, such that as the drum rotates, the cable sort of piling on and moving and kind of makes its way across the threads of the drum, to sort of give you that take up technique. The reason we like groove drums is because we get a very consistent amount of take up for every wrap of cable. And it's always going to be the same because of that sort of nature of wrapping in those grooves. If we were to do a sort of traditional smooth drum like you see on some things, you then have that problem where the cable can pile on itself and do other things, which if you're just trying to hoist something and sort of move it, not a big deal. But if you're actually trying to position and be repeatable, that piling on and those different wraps can become problematic. And so we stick with groove drums. Usually these days, machines involve some sort of feedback device, so that we can go back to our control systems. In the case of our Hudson winch, we have a little box here we call limit box that has a rotary limit switch that we use for sort of end of travel limits, and then an encoder inside that box that we use for positioning. And that, again, we have just a little roller chain stage that connects the rotating drum to that limit box to go through that travel. In many systems, you will also have either an encoder on the motor, either that encoder and not an encoder here, or secondary encoder on the motor. Kind of depends a little bit more on the controls. And I think the last couple sort of useful details here, and then I'll probably let Loren, I think you might be back, but jump back in. But usually we're going to end up with a loop of cable coming off of this that we're going to drive. So we're going to, come off one side of the drum and go out to our pallet or whatever. We're going to loop back around and bring the other end of that cable back into the drum so that we essentially have a closed loop. And the nice part of that is it means that, like, again, with the groove drum, every time we sort of let a foot of cable out, we can take a foot of cable up on the other side, and we can kind of maintain this closed loop system. in order to make that sort of stable and work well, we want to be able to tension. And so at least in our winch, and I think you see this in many sort of typical deck winches, there's sort of some kind of built-in tensioning system. We have a set of shivs on a shaft here at the bottom. And that shaft can be driven back and forth with this threaded rod. And that lets us, make that loop of cable. And then by bringing those shivs back, we can kind of tension that whole loop. And then, different people have different styles. We have some outriggers if we need to go and divert those cables a different direction. But I think that's kind of the basic gist of it. I don't know, Loren, what else do you have to add?
Loren, are you back with us? Can you unmute one of your,
Yeah, I'm sort of back. I've got my iPad out in the hallway in case this happens again. So anyway, we'll try to see it. I can show you some images of a couple of deck winches if I can share the screen, and I'm taking a chance with this.
Yeah.
Can I do that? Let's see. Fingers crossed.
no pressure.
Disable participant screen share. Oh, host disabled. Okay.
Oh, I gotta Loren, I think I have to make you a co-host again because you went away and came back again.
Yeah, sorry about the problems, guys. I live in the boonies and internet out here is a little weird, so.
Okay, you're now the co-host, so you should be able to share.
So let's see if we get some of these up here. Disabled participant screen sharing. They're not letting me do it.
Is this
I'm
an
in here
image,
twice.
Loren, is this an image that was in the latest update? Or no?
Yeah, I don't know. I'm apparently on here twice. I'm sorry. folks.
Okay, now we'll sort it out. What I'd like you to do is, why don't you quit out of the session? And Sarah, is there a way to make sure that there's only, quit out of the session and then come back again?
All right.
Hopefully we'll only have one of you.
Yeah, okay.
So many reasons.
He's logged on with 2 devices, so.
Yeah,
you're
that's
logged
the
on.
problem.
Loren, you're gonna have to
Yeah.
kill the iPad.
iPad is going to die. There we go.
Okay.
Again, sorry. Technology is not my big thing.
There's a number of people who just cocked their head to the side and said, "What did he say?"
So let's see if this will work now. No, I'm still disabled, but I have just some images of the very winches that Chuck was showing. There's one from CSU Fullerton that is a pretty standard unit. I have one that we have at my old university. Let's see here.
Are these, Loren, are these images on the outline that you sent to Chuck and me this morning?
They're not, no, they're not on the outline. Yeah.
All right.
I just have to be able to share my screen, but that's okay. Don't worry.
You're not able to share? Is that what's going on?
No.
Okay. My recommendation, Loren, is to quit from the program, quit out of the meeting and come back again. And Chuck, are you okay to move forward?
Sure. Yeah, absolutely.
Okay.
Okay.
Just gonna see where our outline was headed. Yeah, so I can just touch on a few of the things that Loren had sort of mentioned. As I think I sort of pointed out, like we were talking about, groove drums is sort of, I think, the preference and most of what you'll sort of typically see. There are some approaches that are sort of different takes on how do you make use of this groove drum. And I think the options you sort of typically see are either, what we would typically do is we will anchor an end of a cable into one side of the drum. We will then sort of go out to our load and our shivs and come back into our drum and anchor the other end of the cable into the drum. And we do that with, actually bringing the cable through a hole in the drum and clamping it down onto these little sort of bolt pads that we've built in. Like I said, that means that we are, we have a loop of cable. We've
Did you
tensioned
hit
that
your
loop,
space bar?
and we have a tensioning thing that we've connected somehow we have to then connect the load to the cable. And I think we'll come back to that in a minute. Another approach that you will see, which, has its place sometimes, is that rather than making that hard anchoring to the drum, I think we are probably all aware of the idea that if we were to wrap the cable around this drum a couple times, we could probably develop suitable friction with some tension, that it won't slip. Think about those those wraps you put around a pin on a fly rail, same idea. And that is another option that you'll see people do, where they'll just take 3 or 4 wraps of their cable around there, and then the terminating of the cable can all be done sort of out at the load. We just don't, our experience and my practice has been, we don't like to trust that friction if we absolutely don't have to. If we have applications, we use that method if we must, but our preference would always be to sort of terminate back to the drum where we can.
Hey, Chuck, can I interrupt for a second?
Absolutely.
Are you working with an image on the screen?
Oh, sorry. Did I turn the share off? Didn't I? I apologize.
Yeah.
Sorry. Let me put that back up. My apologies.
I promise, folks, these guys are really good at deck winches.
Maybe not as good at Zoom meetings, unfortunately. Sorry about that. But yeah, so just a quick recap, right? We could come in through a groove and anchor into these plates inside the drum to clamp that cable off, or we could simply put a few wraps around on that drum. As I was saying, our preference is definitely they anchor the ends at the machine. That way we kind of know nothing can slip at the machine end of it. And that's how we kind of get our loop and our motion through there. With a smooth drum or a pylon drum, that gets really hard to do. Again, that sort of changing diameter situation makes that just about impossible to make work. Just kind of going back to the Loren's. Oh yeah, go ahead, Loren. Yeah, I was just talking about doing sort of friction, around a groove drum as opposed to anchoring to a groove drum. I don't know if there's other methods you want to talk about.
I think I can show you a couple things that if we can try this.
Sure. Yeah.
Hang on a second, Loren. I have to find you to make you a co-host.
I'm right here.
Yeah. Well, hang on a second.
And if this fails, I'm just going to have to give up on that. But sorry about the problems. We have more cows than people in this town, so the internet gets stomped on occasionally.
Right. I'm still trying to find you in my while I'm looking for Loren. Chuck, we've been asked if you can show a detail of the quick pins. Do you have that?
Sure.
Do you have that ability?
I do. Let me open another file real quick, but I can definitely show that detail.
Are you guys still using those?
We build them onto the machines just because we are adverse to change, shall I say, set in our ways, maybe.
You still put cranks on them?
We still give you that option. We usually replace the pins with bolts these days, just so that we know nothing ever slips or moves or anything. But we do put them in there. Let's see if this drawing,
Problems that I had with those is that if you really get a high torque on that those pins can get bent and then you can't get them out.
Yeah. So I don't know. Do I have this part pulled out anywhere? Let's see. Oh, this might be a little cleaner. Oh,
Don't forget to share your screen.
oh, right. Sorry. Okay, let me give you this again. Let's see. Can everybody see my CAD now?
Yep.
Okay, so we have this sprocket that's on this gear output of this gearbox, and what we have done is we have taken you can sort of see this brown that highlighted item. That is a purchasable item that's sold in industry as actually a slip clutch. So this sprocket is sort of on a hub between two plates with some friction surfaces in here. We essentially defeat all of that slip capability by drilling some holes through it. And as you can see in this picture, we have some sort of quick release pins that we put through there. As Loren was pointing out, you know, if you get a big shock load on these, you can have problems. We now much more typically when we deploy these winches, replace those pins with grade 8 bolts, because I cannot remember the last time somebody actually wanted to use the hand crank function. But we have these winches around in our shop by the literally hundreds of them here in the shop and deployed in the world. We have not really altered their design other than to substitute parts that are no longer available. And so mostly out of consistency more than anything else, we've stuck with this detail. But that's sort of the gist of it there.
Let me ask a question then that comes to mind. If you get in a like a power outage, some kind of a failure mode, and you need to get said pallet or unit off the stage, and you don't have power to do it, would this be the way that you would go about doing it?
Yeah, I mean, these days it would. I mean, apart from the fact that most of the stuff that we do, and I know people had asked some questions about this, I think you had sent earlier, you know, most of the stuff we're building, we have a way usually to disconnect the wagon, pallet, skid, whatever it may be, from the actual drive cable, usually in the form of a knife, what we call a knife into a dog. And so often we would just, get out of jail that way, pull the knife out of the drive dog that's connected to the cable and push the thing off stage by hand. But in those cases where we're like rigidly, permanently attached to the cable, yeah, somebody has to come and pull a couple bolts and then crank this thing off stage or push the actual unit and just let the drum kind of spin with it. As we, I'm sure, Bill, you've had to confront this, but when we get into like looking at flying systems, whether it's for scenery or people or anything else, that becomes a much bigger sort of question and debate about how to deal with that particular
Right.
no power problem. You don't obviously want to, there are just going to be times where you just can't leave the load hanging up there and you have to have a solution. And that gets a lot more complicated. We as much as we can with deck winches try to keep things pretty stupid simple where we can.
Okay. Yeah. Rescuing a performer, somebody in the air, is a much more serious matter, and you got to pay more attention to it.
Yeah, absolutely. Loren, I was trying to sort of follow through with your outline there. I don't know where you wanted to head next.
Well, if I can share a screen now, I can just run through a couple of images of what we've been talking about. Let me see if I can. Here we go. There we are. Here, this one. Okay. Hopefully I won't crash. So this is a typical winch that you've just been talking about. This is one built by the students at CSU Fullerton. And they have a dozen of them or so. You can see the same outfeed shivs there at the bottom that also do the tensioning with the shafts here, and the drum and limit switches and so on. We're going to try to do another picture. Hold on. That's another view of the same thing. Basically, it's the same design that you'll see around the world. Another version of this is the one from SDSU. This is the winches that I designed, and they have the drive package attached to them. These are designed to be shipped out and rented to other people. But the same thing, you see the tension shivs at the bottom here. We don't have the disconnect that that Chuck was talking about, because we have faith in our winches. And if we lose power, then we're going to send the audience home in the emergency lighting. So this is just another view of the same basic design. So there's not much to it. Then you were talking about the friction. That's a hold on a second. Let me see here. Friction winches are a little bit different animal. What we've done, instead of using a drum to try to drive it with friction, we actually use a 3-groove Shiv. This is a compact crank manual winch that you bring the cable in from the dog, comes up around this first groove of this pulley, comes down around the first groove of the tension pulley, back up around the second groove of the drive pulley, around the second groove of the tension pulley, and then out to the other side of the dog. And this is a very inexpensive way of doing winch for not too heavy wagons. I mean, I've had 1,000-pound wagons that I've been able to move reliably with these, but that depends on your floor surface and your casters and so on, that, you know, how much friction you're creating there. And this is less than $500 to put this together. That's the view of it right there.
Other than the economics, are there other advantages to doing something like this, whether you hand crank it or motorize it?
Well, certainly cost is the biggest factor, because, you know, to put a motor on it, then you have to put a drive system on the motor, and then you have to have a control system on top of that, and the price goes up exponentially. For small venues, you know, community theaters or college theaters, something like this can drive not only wagons across the stage, but you can use it on a turntable as well. And that's why this has 2 speeds. You have this geared system here to haul heavy freight on like a deck, and then you have this direct drive. You can change the handle from here to there, so you're directly driving this pulley here for like a turntable, because the ratio between that pulley and the turntable is so different. They have a good mechanical advantage. So
Yeah, and I would add that we have in essence a motorized version of something, you know, same exact concept, just with, you know, a motor driven sort of 3-groove pulley and an idler pulley that we have used for many years to do turntable drives, where we would buy, you know, in essence a big endless loop cable that we would have someone long splice for us, that we would wrap around the perimeter of the turntable and reeve through those friction shivs. And for many years, that was sort of our go-to turntable drive, and it worked exceedingly well, you know,
yeah,
with no problem. So, you know, there's definitely a time and a place for it. There's no question.
this is just
The
another
magic words, however, long splice.
Yeah.
Let's talk about the fact that you need something like that, because at some point, correct me if I'm wrong, but at some point you're going to be driving the connection of the wire rope. You're going to be driving it through the system.
Certainly in the turntable application all the time. Yeah, I mean, we'll be doing it over and over and over again. So that splice becomes critical. We actually many years ago found a vendor that does that work for sort of the carnival, you know, fair merry-go-round and Ferris wheels and that kind of stuff trade, and we buy those cables pre-made by them, because they know how to do it, and you give them a length, and it, you know, a week later a loop of cable shows up beautifully spliced. You'd never know there was an end. It's pretty amazing when you have someone that knows what they're doing do that long splice.
For those of you looking for a long splice and you can't find the old folks from the carnies to do it for you, a ski resort is a good place.
Sure, yeah.
Because they need them for the chairlifts.
Yep.
Well, you can do them yourself.
No, there you are. Okay, sorry.
You can actually do them yourself, but don't expect to succeed the first time.
Right.
Yep.
Okay.
Where'd you want to head next, Loren?
Okay, so we looked at the winches. Now, winches are not the only way to move the Stingray is probably the cheapest because wire rope is cheap and the winches are fairly well understood. But and I've tried a few of these, but I've seen them in the industry, especially the cruise industry, that you can, instead of using a winch with a cable, you can use a motor with a timing belt. And you have a very long timing belt that goes clear across the stage to a dead end timing belt pulley and then back to the motor. What makes the advantage of these is super simple. You just stick a sprocket on it. There you go. You just stick a sprocket on a motor and you put the timing belt around it. You have some means of tensioning it, often on the opposite end. The dead end usually can move and tension the belt. And it's very accurate because there's no slip involved at all. In a system like this, very little stretch with the Kevlar belts these days. And it's a pretty useful way to move stuff. And the cruise ships are used, or at least they used to. The cruise ships that I've been on have used the system quite a bit, but they've all now, most of the new ones coming out from Royal Caribbean anyway, have switched to push chains instead. So, but before we get to that, you can imagine this same system here. You could adapt this to not just to timing belts, but you could use roller chain as well. But it tends to be a bit noisy. And plus it's way more expensive than cable. You want to move a platform 40 feet, you got to have 80 feet plus of roller chain. And there's no way to make them quiet really, because just the nature of a sprocket meeting a roller creates noise. But it is a way to make it work.
Yeah, Loren, before you leave this image, I want to make sure that we're all clear on how this actually works.
Yeah, and I should say the image I popped up was the only one I could find with a belt drive, which is a slight variant of what Loren was talking about. I think in Loren's description, he was like sort of ignore the sort of gray and stuff here, but just a loop of belt essentially replacing that loop of cable we talked about. So just long, endless loop of belt that would be attached at the load. And just driven by this single sprocket. The application I'm showing here is a little variation we actually have on the shop floor right now, where for a variety of reasons, mostly because we have these wagons that have all this other equipment in them. They move a very short travel, only about 5 feet. We chose to put the machine in the wagon so that we could keep the deck a little easier. So this machine is just gear motor with a pulley on the output. These are just idlers. And what we end up with is a piece of belt that is anchored to the stage floor at its ends. And then kind of like an old film loop projector, this belt loops up in and through this machine and then back to the dead end. And the machine is kind of moving back and forth on this sort of fixed piece of belt, so it can kind of pull itself from end to end. So subtle, a little variation on what Loren described, but I think that does, point out the timing belt. No question that this was an application where, as a shop that's been just doing stuff year after year after year, you sort of start to amass parts and pieces, and we had these parts, and so it worked out and sort of was cost effective. But if you're looking to start from scratch, the belting and the belt pulleys can get very expensive very quickly. I think in a cruise ship application or a permanent install like that probably makes a lot of sense, because it probably helps them on maintenance and reliability kind of issues. They don't have to worry about cable stretch and those kinds of things. The parts are a little simpler, but if you're looking at this sort of for your typical theatrical application, it does get pretty cost prohibitive pretty quickly. Has been our experience.
Yeah. So Stephanie had brought up a question or a comment actually about drums being really expensive. Helically grooved drums are they're not cheap at all. I was looking at this thinking that this might be an inexpensive alternative, but I take it from what you just said that maybe not.
I think that if you were apples and oranges, the pulley certainly is going to cost you less than having a drum made. The problem gets into when the belt's costing, some of these belts, they're pricing by the millimeter, with dollars attached to those millimeters, as opposed to the cents or quarters we're paying for a foot of cable is you just can't compare. So when you look at, well, yeah, maybe this pulley was only $200 instead of my $1,200 drum. If I have to go spend $3,000 on my 80 feet of belt, that's a whole lot more than the $80 a cable I had to spend. So that's where it sort of falls apart, at least as in our experience.
Okay.
So, one of the things he mentioned here is that this is on a piece of equipment. The motor is actually mounted on the thing that's moving. So basically, it's crawling along the drive.
Yep.
If you can let me share my screen.
Yeah, sure.
Different version here.
Every time we do this, we take our life in our hands.
This is the same idea, what he's got going there. This is very simple. In this case, the chain, I call this a self-climber. The chain is stationary in the track. And the track is no more than 3/4 inches deep. In fact, that's all we ever used at San Diego State for the last 25 years. Our deck tracks have been 3/4 inches deep, unless we were going to some kind of box track for a special occasion. So basically what this guy here does is the motor crawls along that chain, it picks it up, moves it back and forth, but the chain itself stays stationary, so the wagon moves back and forth. You can do the same thing with wire rope in a 3-groove Shiv, but you have to, there's more involved to it to get it to tension up and so on. And here, to take the tension out of the chain, all you would do is you would put a turnbuckle at that stage end or something like that and crank it tight. So this is a very inexpensive way. Roller chain is cheaper than timing belt for sure.
Yeah, absolutely.
And here again, you have the problem of roller chain noise. I've driven a platform that was 40 feet wide and 12 feet deep in a 3/4 inch track with this system reliably. Something about that lead sprocket right there likes to stay in the chain. It doesn't want to pop out. So even though you're pushing this platform the hard way, it worked pretty well. The problem is, of course, then you have to get power to this, and how do you and we'll talk about that in a minute, but getting power to a moving platform can be problematic sometimes. That's what
Yeah, I'm getting a question. They're asking about how to get power and control.
Yeah, I mean, I can say quickly, in the example I threw up, we had, these are these wagons that have, a part of a band on them and a whole bunch of lighting in them. So thankfully that cable management became a sort of show wide problem, not just an automation wide problem. And because you don't see the offstage sides, we did some very simple cable loop kind of situations. Obviously that's not always a possibility. And that's why more often than not, we're going to go back to a sort of conventional winch, off stage, driving a cable in the deck, so we don't have to deal with those problems. But this was just a sort of one of those cases where it worked out.
Right.
For us. I can show an example of cable management here if you like.
Yes, please.
Get the right one here. So this is a self-paging cable tray. We're looking at plan view here. Here's the wagon that moves up and down stage. And this is simply a wooden trough with a hinged elbow, just like your arm, and it moves out and follows the wagon down and then retracts as it moves up stage. If you're like sending a slip stage from upstage to downstage, this is fine because your system will hide this. Your platform will hide this, but oops, that's a dog. Never mind. This just is a detail of the same thing at elbow there. Other ways to do that, of course, would be things like retractable cable reels that you sit on the side of the track and you attach it to the dog and it drags the cable behind it. You can do a festoon. If I can get that up, I can show that. Let's see. festive here. This was my solution when doing the show Damn Yankees. It was a Broadway revival of Damn Yankees that premiered at the Old Globe. And I had the energy chain, or what they call it, the cable carriers, the plastic cable carriers that carried. I had designed a deck that would allow these cable carriers to follow the dog and send power and pneumatics and hydraulics and everything to them. And unlike the New York version where they lay them on their side and they slip out, they uncoil sight on their sides, I'd made mine vertical, which I'd seen on more machinery that would unfold like, you know, those New Year's Eve blowers. They fold out like that. And the problem was stage manager dropped a pencil and it landed in the track and got in that cable tray or cable carrier, this plastic cable carrier, and actually split the thing. And that happened twice, and it turned out to be a real headache. So what we did instead, we set this up. I think you can see in the image here. You have a weight right there that's picking up pulley. That's picking up slack out of a cable. So as the platform moves on stage, it raises the weight, and that's a solution. I'm not saying it's a good solution, but if you had to punt, that's one way to do it. And I think the rest are that'll do for now.
Yeah,
Okay.
I can pop up real quick here. Let me see if I can just find it real. Where to go? Just so that everyone kind of knows what Loren's talking about with the cable carriers, if you're not familiar with that. But you know, made for industry, there is this product, you know, some people talk about it as IGUS. You'll hear Cable Schlepp is another company, but essentially it's a plastic chain sort of that gives you a hollow interior space. And you can fill that with, you know, cables and hoses and things that you need. We tend to, as Loren pointed out, we tend to lay them on their sides. So this is sort of a typical cross section through one of our deck tracks where we have to do that energy sort of management. So we have a fixed end of that, and then there's an end connected to the moving dog, and you can then run your cables in there, and they kind of just act as a big loop. Trying to find a plan view. So yeah, you can sort of get the idea here, but this is that energy chain. This is our dog on its side. This is that chain sort of at one end of the travel, and then as it moves through its range, here it is at the other end of the travel. That material can get pretty expensive. You know, putting all the cables in it is a drag, and like Loren said, it's, you know, often, as this section kind of proves, it's down in the deck and buried. So if you have stuff getting in there and stuff, it can be problematic. But when you just don't have a space to go anywhere else, this is what we often have to kind of resort to get cable when we need, you know, be it lighting power, pneumatic power, electrical power for other stuff out to our wagons. That's sort of what we did. And I know there were some questions on dogs and stuff. I think Loren started to bring up some pictures, but it might just be a good thing. But I thought, you know, this is sort of like not a typical kind of Broadway style wooden framed deck with a track in it, where we really this is just an all wood frame, wooden lids, with some kind of finished top surface. We just do a very simple wooden kind of framed track body, we call it. And we have this dog that runs through it. And then, as you can see, the idea is that we have return cable on either side, and we have shivs that allow that to fit. And then we attach that dog to the cable loop that we've talked about being driven by the winch to pull the load back and forth. And at least in our example, and there are as many dogs out there, I think, as there are sort of people that have designed deck winches, it feels like. But this is kind of our bread and butter, run-of-the-mill dog. Plastic layer on the bottom, so we have something smooth riding on the bottom of that track. And then this is just all flat metal parts that we weld up. At the ends, we have these blocks, these steel blocks that have 2 tapped holes in each And that's how we anchor the dog onto the cable. And I know, Bill, somebody had sent I think a question in advance about, does this really work? And, we've had issues with slip. And I just wanted to sort of comment on that. I mean, we have been doing this style dog for as long as I've been at Hudson. And I know for many years before I got the Hudson, this was the same detail. We have had little to no episodes of slip. And I think that can be attributed to two reasons. One is, these are big, heavy, solid steel blocks that get tapped for set screws. And we have 4 of them on every dog. So there's, multiple points of sort of anchor and clamping there onto the cable. But I think the other is, and I tried to sort of sketch this yellow line in to sort of best illustrate, but a huge amount of why this dog doesn't want to slip is just the sheer friction of coming out of this block, bending around this sort of center knife receiver area, and then back into the other block. And you bend that cable around kind of all those hard corners. I've probably actually made it look nicer than it really is in the drawing. In addition to cranking down those 4 set screws real well. And we've moved 1,000+ multi-1,000 pound wagons when you get up to sort of 3/8 cable and a sort of bigger version, same details, just bigger of this, without any problems. So, I know there are, like I said, there are many, many different designs of this, but I think it can be done effectively to do a sort of friction-based anchor. We rely on friction-based anchors for all kinds of other rigging purposes and take advantage of them. So it's really the same idea here, just, enough friction surfaces and enough friction from those screws to crank onto the cable.
I just want to make sure everybody understands that the bottom image with the cable, the yellow cable running through it, is a top view. And
Yes.
the image above it is an elevation, right?
Yes. So yeah, the cable would sort of be running at the plan. You can sort of see on that end section view, the cable's kind of running at this height through the blocks and around these sort of center ear sections that we have.
To give you an idea how old this design basically is, I remember using these when I worked for Pete Fellers Senior.
Yeah, no, I'm sure this was not a Hudson original design. We may have put some corners on it and change the pieces a little because we can get them, laser jet and water cut and all those kinds of things now. But I think the fundamental basic design certainly predates me and my time at Hudson. So it's pretty tried and true. And I would say, just while we're here, like we were saying before about that disconnecting of the platforms, this design dog is designed to have a knife inserted into it. And that is a 1/4 inch by 2 inch, that's as standardized across the industry as I have found something is the 1/4 by 2 flat bar knife and receiver seems to be one of the few things that most people agree upon.
Right. And that the knife, which is not shown in this image, that just sits in there. There's no captive device or mechanism.
Yep, it just
in there.
just simply, just engages, just slides in and engages, side to side with those 2 ears and engages down into those 2 side plates lower down to sort of capture it. But yeah, it's really, it's a pretty simple thing, but it seems to work remarkably well.
Okay, great. Well, thank you.
Yeah.
We've got a half an hour left to the official section. I want to remind the group that your questions are welcome. If you've got something you want us to talk about, please throw it into the chat and we'll get after it.
One of the things I just wanted to mention, that dog design is kind of fun, and you have your standard ones that you might use, but you may have other problems that you're trying to solve with the dog. I've had some that have traveled out and plugged themselves in when we needed to send power out to something and didn't have a way to do it through the track. It actually went out and had 2 little ball catches that ran up onto a couple of copper strips, and they allowed the lighting to be changed on the platform. And a lot of the problems about getting power to platforms has been solved by wireless DMX, because it seems like we're always running power for lighting effects, and we don't have to do that anymore. So that's a good thing. So if I could show a couple of dogs, if you like.
Yeah, that'd be great.
Okay, let's see if it'll work.
Yep, a couple of dogs. And then Billy was asking about turtles. So we'll put, and I've always liked turtles.
Okay.
So we'll put, maybe put some turtles up in the on deck circle.
Sure.
Sure. So here's a dog that we use it for our box tracks at San Diego State. Wrong slide. Fits in a box track. Really, to call it a box track is it's a track designed to go. If we need to put a track down and we're using a platform deck, our standard platform height, this matches it. So we can slap a few platforms on either side of this and build a track into the system like that. In this case, this dog would be attached to the cable, not with friction, but with an actual thimble and the wire rope connection right there, swaged in. And you can see how it looks in the track. You got the same slot to drop that knife into. The UHMW is a pretty tough material, and it's very easy to machine, so you don't have to have any particular skills. But you can use a drill press and a chop saw. You can make this particular dog. So, let's see if there might be one other item here. Let's see if I can find it. Bear with me just a moment.
Loren, while you're, go ahead and keep looking for that. Philip asked a question that I think's appropriate now. And he says, what height are the deck boxes used with the dogs and knives that Chuck just showed?
Good question.
Yeah, we can, our preferred standard off the shelf box, we build from, 5/4 by 6 with 3/4 inch lids and a 1/4 inch finished surface. So you got 1 inch and 5.5. We tend to put them on, some kind of little legs. So you're looking at least 6 3/4 as kind of the shortest we make that standard box. That was our sort of preference. It doesn't often get to be that. We've done that deck, we can do that deck pretty effectively in about 4 inches without a problem. When we start getting below that, we have to start changing some parts and pieces, and that, at least in sort of at the commercial, trying to do it all the time level, gets harder. I'm gonna grab the screen again, and I can sort of just show you an exercise. This is probably now almost 15 years ago, went through a sort of exercise to address that exact question of kind of what were all the standard details we needed and how could we do it. And so we kind of have this little grid of standard cross sections that we worked out. With this was long ago, kind of how we were building some of our sort of touring decks out of aluminum angle. But I think the critical dimension you can see here is that we really would like there to be 2 inches available to fit our standard dog and Shiv parts. And when we went through this sort of process of trying to standardize all this stuff, like I said, about 15 years ago, what we really found was that we were spending an inordinate amount of time redesigning dogs and Shivs, like almost on a per show basis, for no great reason other than, we just hadn't forced ourselves to standardize. And so we went through this, couple month period where we had someone working on these details, and we came up with kind of all the parameters we came to. And out of it came this sort of collection of parts and pieces, which was a set of standard Shivs and a set of standard dogs. And I can tell you that if there is nothing else we ever did well at Hudson Scenic, this exercise was it. Because developing, and it really came down to these 6 Shivs more than anything. These are a 4.5 inch, a single, a double, and what we call a pincher, and then a 6 inch variant of that single, double, and pincher Shiv. But those 6 items we have probably made more of and gotten more use out of than anything else we've ever come up with here. We just keep them on the shelf. We use them for everything. And it, now you don't think about, well, I have to do something and I have to move some cables around. You're going to use one of these shivs because we have it and we went through all the R&D and effort and came up with the ways to build them. And really the same thing sort of became true about our dogs and some of our deck details. Like once we got this set of standard details, we've just used it forever. And like I was saying, this is kind of our go-to, that 5/4 framing, 6 framing with the track in it. But we have some options, we kind of have the thinner version. If we need to squeeze it down, we can play games with the track. We can put it in a metal framed thing if we really want to. And we've played around with that a little bit, but that's kind of what we use as our limits. And we've, evolved a little. We use some extrusions and things now for this thin metal deck, but given our choices of time and energy and capability, this is what we're going to go to time and again, is this wood framed deck with this sort of classic 2-inch thick deck track, because it just makes all our parts work.
So the advantage of that, I mean, if you're a business and you're sending these things out, you need to have a standard size for it, but in a university setting, which I spent a lot of time, a large part of what we're trying to do is experiment and come up with interesting and different ways to do things. And what basically between CSU Fullerton, my colleague Bill Meyer and I have done, we've been in a contest to try to make our deck tracks as shallow as possible. And for the last 25 years, we've had 3/4 inch deck tracks at San Diego, and he's got 1-inch deck tracks at Fullerton. All it means for us is we put a sacrificial layer of 3/4 MDF on the stage, and then wherever we need a track, we open a 3.5 inch wide gap in there and replace it with a strip of 1/2 inch plywood that has a piece of hardboard attached to it that covers the return cable, and it just leaves the exposed drive cable in the slot that also guides the wagon. It's very shallow, and sometimes there can be problems it wants to pop out if the wagon isn't balanced well, but it is significantly cheaper than having to build box tracks and then platform the whole stage to meet those box tracks.
Absolutely. Makes perfect sense. I'm just going to jump back real quick on you, Loren, I think we quickly breezed over, but at one point, Loren was mentioned about the sort of one of the new things in sort of deck tracks that you see on the ships. And we did these years ago at request was this idea of push chain. This is this sort of unicorn of a product, but it is a metal chain product that can be driven with a sprocket leg driver, but that when sort of pushed and unfolded, it makes a semi-rigid column. It needs to be guided. It won't just do that on its own. It has to sort of be in some kind of guided. It has all these little rollers on it that sort of make it work. But it is an interesting concept. You get a little driver package that the manufacturer makes that you drive with a motor. Then you have the chain. We made our sort of full stage guides out of just some plastic UHMW blocks here. You can see that was fairly easy sort of router or even table saw work that guided the chain across the deck. And it worked pretty well. We did this at a request of a customer for a touring application. So we had, half stage 32-foot tracks that we had to drive, that in a 16-foot platform, we could sort of store all the chain for that track. And that was how it toured. It did mean when you set the show up, you just sort of drop these things. You could just drop these platforms in and away it went. They are incredibly heavy. This material is incredibly expensive, and it's pretty loud. I don't know what your experience, Loren, has been, but but we did it once, and they loved it for the tourability and didn't like all the other aspects of it. So we have not ever gone back to it. But I can again see on a cruise ship situation where you have sort of more control and maintenance stuff, it probably is a pretty nice permanent install application.
You get the
Well,
band to play
the
louder.
nice thing,
You get the band to play louder.
Yeah, exactly.
yeah. Well, the nice thing about, and why they use on the cruise ship, I think especially, is that you can have crossing tracks then. So
Yep.
because the dogs come out from wherever they're stored, you don't have to worry about one track crossing over the other. Like if you have a platform that's all the way across the stage dragging a cable behind it, you can't send another one down from upstage.
Right.
So these are really wonderful, and they're reasonably quiet on the cruise ships because they're built in under the deck. The band is always playing loudly, especially when anything's moving. So it seems to work very well for them.
Yeah, no, the crossing
Yeah.
track thing is a great capability that this does give you. That is absolutely true. And one of the few times we've gone back to it has been for that very reason. When we had to do some crossing tracks, it works really well.
And one of the things we have to test when we're inspecting these things is we try to make them collide. You know, have one of these push chains coming down from the upstage, another coming across from side stage, and see if they'll stop when they're supposed to. And usually they do.
But that's not a function of the track itself. That's a proximity sensor or something like that.
The sensors, right? Generally a proximity sensor or something like that, plus the encoder is telling them where it is. There's several safeguards. I have not yet been able to get them to collide.
Well, you keep
Dry
trying.
try.
You keep trying.
Yeah.
I want to. I know we were going to talk about turtles, and I promised to get back to that. But I want to take a jump back to the beginning of the session today, because Warren asked a question, and I think I understand what he's saying. I'll just read it. Does the drum configuration travel enough for fleet angle to be a consideration? So do we need a little clarity from Warren, or do you know what he's referring
Well,
to?
we're talking about, okay, with the cable moving back and forth across the drum?
That's my assumption, yes.
Yes, okay, well, those outfeed shivs in the standard deck winches that also are the tensioning shivs, that axle that they're on is actually stationary. So when these pulleys, and generally a bronze bearing in there rather than any special bearing, in fact, it's better to be a bronze bearing, that with that outfeed shiv shaft stationary, these pulleys will tend to wind themselves along to line up with the cable that's on the drum. Unless the distance between the drum and the outfeed shiv is longer than the distance to the first deck shiv or whatever you want, first obstruction. There you go. Okay, so those shivs will wander back and forth on that shaft, and they'll follow the cable on the drum as long as the distance between them and the drum is shorter than the distance from the pulley to whatever you're getting into in the track. And it works pretty well, but you do have to allow distance from the end of the track with these in order to account for that fact that the thing's moving back and forth 6, 8, 12 inches.
Yeah, I think it's important. Yeah, it's a good point too to know, like when you're thinking about their track, right? Like if we need to go really far, that cable, that one cable could sort of come, all the way from this edge of that winch and end up, having traversed, 10 or 12 inches across. So you kind of have to think about that as you're going into your track design. I was trying to see if I thought I had a drawing of a deck open that might illustrate that point for us.
One of the problems is some people think, well, let's put a ball bearing. This is a ball bearing shift for that. No, that doesn't work. It won't slide on the shaft. Or let's let the shaft be supported on bearings. No, that won't work either. It really is that action between the shaft and the bronze bearing that allows it to rotate and slide at the same time.
Yeah.
And that's
So,
why we didn't
so this is
do
like a
these winches.
kind of classic example of, there's one of those winches, and we need a fair amount of distance to keep that fleet problem resolved. But also you can sort of see we spend not in time actually drawing, okay, that cable's going to move from here to the other end, so that you can look at how wide does this kind of runoff track need to be in order to accommodate the fact that that cable's moving through that path. So it is something to think about. I mean, like I said, I don't want to get us too distracted, but to Bill's point, the solution that we occasionally go to when that doesn't work for us is we have developed over the years. That's not the right one. That's not the right one. Where'd it go?
Interesting looking set.
Where did I had it open? Which one is it? This one? Yeah, this one will do it. Maybe. No, sorry guys.
That's a turtle.
Too many drawings open. Let's look at this one. No, that's not it either. I thought I had one which showed a sort of classic, like how we solve this with a fleeting winch, but it's not. Oh, well, this will be one. This is a little hard to see, but I don't know if you guys can see this sort of poorly light dark purple that I can't seem to get changed. But this is a winch that has a very small drum right here. But you can see we have no distance between the winch and the shivs, and that's because this winch actually moves while it is reeving and unreeving. We call it zero fleet. So the cable is always coming off in the exact same location, so that we can sort of solve that problem of the cables moving around by moving the winch back and forth. Obviously makes for a far more complex machine. So we don't like to do this unless we have to, but on occasion you don't have a choice.
For those of you who are familiar with the package hoist coming out of ETC and Wenger, their basic ones anyway, are zero fleet, and basically it moves the winch assembly relative to the loft block, or the initial block, if you will, so that is a 90-degree angle all the time.
Yeah, this actually is a little better, clearer picture of the same idea, but this is a slightly different model of that machine. But this machine sits stationary. You can see our grooved drum here, and you can kind of see the red image is the drum at one end of its travel, and this gray outline is the drum at the other end of its travel. The cables are always coming in at this one location right here, and so as this drum rotates, in this case, the drum itself, the machine is all stationary, and just the drum is moving back and forth on this special splined shaft as it rotates. But that means that we don't have to worry about those fleet problems. So you can see we have our first set of shivs, directly in line with the machine, but makes for, we were saying before, the drums themselves get expensive. When you add this sort of fancy spline bearing arrangement in there, it gets even more expensive. This was a case of, built to order by a customer that required it. So not something we would do regularly, but, is a solution to that problem if it's a problem you have to solve.
Folks, we have about 15 minutes left in the official. We might run over a little
Got
bit.
it. I think you people were asking about turtles. I thought I would put this up there as at least an example. This is the sort of standard. This is actually one of the first projects I got to do from scratch when I started at Hudson. We were looking to get to a standardized turtle product that we could use on shows. So this is a little 2 horsepower turtle that we've used on many projects.
What was the turtle again?
What's a turtle?
Turtle.
Yeah.
Oh, yes. So this is a wagon that wants to move across stage, but also be able to rotate. You need a device in there that deals with that. So this is what we have built. So in the case of our turtle, we have essentially a little tiny wagon. This is about 3 feet across on the 2 kind of stop sign sides. that is what ultimately gets connected to the deck track and runs across in the track. It has a gear motor with a bearing or with a pinion gear bolted into it, and it can then turn this larger geared bearing, sometimes called a slew ring. And so by bolting a platform down to the top of this outer bearing, this unit can be tracking along a line, and we can rotate a larger wagon around it, so that we can sort of be spinning and tracking at the same time.
Yeah, I think if you think of it as a tank,
Yes.
and I have actually used tank turret gearing, the big ring for
Sure.
larger, some larger units.
Well, on that Jane Eyre 60,000 pound grid, it was a 6-foot diameter slew ring, geared slew ring,
Right.
that was used on that. And they have incredible capacity, I should say, because they're often used, they're called crane bearings sometimes because they're used on cranes that have this big, huge cantilever over there. And they're able to withstand that. And because of that, they're not cheap.
No, yeah, exactly. That is the penalty here. These are some very expensive parts to make a fairly simple thing. But again, like we've said a couple of times, in terms of like a standard product that we just kind of know we can build and count on, it was the sort of simple how to build them over and over solution for sort of commercial application, without a doubt.
Now I can show you a different way of approaching that.
Yeah, I can.
If it's all right, let's see. I'll share this. This is going to be a little hard to understand what's going on here. This is a turtle that we built specifically for trucking grapes of wrath. And what it consists of, this is a 3-foot diameter number 80 roller chain sprocket that's sitting on casters, and it's got a blade welded to it that you can see right here. It's got UHMW on either side. And this is the track it runs in. You can see the cable right there. It's only 3/4 inches deep, but in this case, we lined it with 2 pieces of flat steel. This drags the sprocket up and down stage, which and the truck follows because the truck is sitting on top of this. We got an old surplus golf cart differential, turned it on its side, locked one axle, and set it up so that this sprocket would drive the bigger sprocket. And we had the regular DC golf cart motor and controller and all that, so that when the driver put his foot on the gas, it would actually rotate. And this gear shift, if you change the gear shift, it rotate in a different direction. This whole thing could move. I mean, it was reasonably cheap to do something like this, because even this whole package together, everything we put into this is cheaper than the slew ring that I bought from
I'm sure
surplus from a manufacturer. So I think this shows a little more of the mechanism there. You can see here's the sprocket, and it's sitting on these casters, and there's the blade in the 3/4 inch thick or deep track right there. And then it's got this little pneumatic cylinder here to lock things in place because there's always some play in the system. And it was very effective. There's the truck right there. And it could drive up and down in this track. It's diagonal right there, and then rotate for various scenes. So it worked out really well. I know that it's an option that's far cheaper than trying to buy a slew ring.
Right.
Yeah, no question. No question. This is the sort of Cadillac approach, that slew ring approach.
Yeah.
Can we shift gears, if you'll pardon the pun?
Of course.
I think, and I'm guessing here, but I think some people are interested in turntables, not only for how to drive, but also how to get power to them.
Yeah, sure. I can throw up a turntable image here and just talk briefly about it. I mean, certainly one of our tried and true approaches for a long time was that sort of friction style winch we looked at earlier, that kind of Warren's hand winch, but put a motor on it, and it works pretty well as a turntable winch with a big endless cable. We have more recently, at least at Hudson, gone to interestingly friction drive turntables, which sort of seems counterintuitive, but has proven really beneficial for us for a number of reasons. This is actually this is a lot in a drawing, but this is a turntable. You can sort of see these 4 outer motor blue motors, and then has a inner, or actually it's a donut, that's the outer 4 motors, and a inner turntable, that's the inner 3 motors here. And this is what is going out on all of the productions of Hamilton that are around the world right now. We do a caster up situation. So this is a cross section view at that sort of donut platform. So you can see sort of from here to that edge right there is our donut. And this is just sort of a typical cross section, but we do casters up on a base frame so that the base frame can get down to the floor and be leveled. And then our platform, our actual sort of donut piece platforms, are these fairly thinly framed segments that wrap around. We have a rolled steel fin on the bottom of those that is located by some guide wheels. That's what keeps the donut sort of running true to the circle. So we have 4 of these around the perimeter, kind of on the quadrants to locate. And then we are driving both that donut, not shown in this view, but the turntable as well. That same style fin that goes around is being driven by this sort of pinched friction drive system. So we have a gear motor with a friction wheel directly on the output. And then we have a pinching wheel that uses a sort of spring tension to generate some friction between those. And the sort of clever detail here and all of that you can see. So this sort of pink circle is the drive frame, and we have our friction motor here and our opposing friction wheel, and that's that sort of tensioned line. But the trick of this that has proven to work really well is that both this motor and this friction wheel are all sort of free to pivot on this point, so that as our circle, which as well as we can fabricate it, is never perfectly circular, it gives, moves in and out a little bit and waves a little. Our friction machine can sort of rotate and move with it, so that we always can maintain sort of good friction onto the ring with our driver, even if this is kind of wavering in and out. You can imagine if we were just trying to sort of push a wheel into this in one direction, if the ring kind of moves away from the wheel, you kind of lose all that friction. So that has sort of been our now go-to turntable solution for a couple projects. I don't know, Loren, what your thoughts on turntable drives are.
Well, I can give you a little cheaper alternative. We can share my screen here.
Yeah, sure.
With the advent of CNC routers finding their way into university systems and stuff like that, they become really cheap. We've been able to make large scale sprockets, and you can see right here, this was cut by a CNC machine. This is the underside of our donut at San Diego State. And here's the whole thing in view here. You can see it just in segments that were cut out of 4x8 sheets of UHMW. We built this sprocket. This is, since it's being employed as a donut, we have these inline skate wheels here that will push against the inner turntable in order to allow to keep it centered on there. A couple other images. Are these showing up? I hope they are.
Yeah, no, they look good.
So you can see the whole outer sprocket basically of this, driven by a simple chain drive, and then that's the inner donut there. Let me get to that's a different one. Hold on. Okay, this is what the inner turntable is sitting on. There's our little $800 slew ring surplus. And the spider that we built that Chuck had mentioned that they have a way, it puts the casters in the right place with respect to everything else. And then a little pop-up brake to keep the thing from turning. So this is significantly cheaper. As we were having problems that day.
Lauren, hold up a second. Can you back up one slide?
Yeah.
Yeah.
That one?
So that's how you drive it.
Yeah.
Yeah.
That's how we drive the inner turntable of the donut. The exterior donut part is driven with a chain around the outside of the a number 40 roller chain outside of it.
Right. So you take a roller chain on the outside perimeter, you take a roller chain all the way around, and it goes around a sprocket that's attached to a motor, right? And a gear.
Right.
Okay.
Right.
I asked that. I asked that because Michael Powers asked when Chuck was showing his unit, how come so many motors?
Oh yeah, that's the multiple motors was about overall load and sort of size of package we could get into that touring environment. So, you know, we end up with the cast of 14 all stomping going in one direction. So we wanted a couple horsepower in there based on what we've done. And so in order to get that package to fit in the thickness they would allow for the tour deck, we went with the multiple sort of 1 horsepower friction machines as opposed to trying to, because we could just never fit a higher horsepower machine under there.
Right.
So one caveat that I might add to this, you see down in this image here, when we were putting the sprocket segments on, we put these little pieces of roller chain in there to get them to be at the same distance, you know, properly distanced. Turns out that's a totally bogus idea. You have to wrap the whole thing with the chain. Otherwise, it's going to be, some point it's going to be off just enough to make the train drop. So if you ever do it this way, make sure you wrap the whole thing with chain before you actually screw them down.
Yeah, we learned that one the hard way. On Lion King in New York uses an almost identical detail, maybe a slightly bigger piece of chain, and we learned that lesson the hard way too, Lauren.
Barry Reed's got a question. I'm gonna read it all, and we'll see how we do with it. How do you describe the TT position? 4 o'clock, 9 o'clock, 0 to 60 degrees with turns counter, absolute degrees from 0 to 10,000 or minus 5,000 to plus 5,000?
Yeah, we've I can certainly comment on this one because we've lived through some interesting stuff in the last couple of years on this. For years and years, we on our system, we have always done sort of endless degrees from, you know, minus whatever to plus whatever that the show needed, because it was really based on sort of mostly on the controls to date. You know, we were treating turntables like really, really endlessly long deck tracks, and that just made things easier. But it's not a great solution if you know, need to go make a change early in the show. It often sort of propagates this ugly thing where like all the cues after that. We've recently done a whole bunch of transfers from a theater over in London that has clearly a degrees and revolutions kind of counter situation going on. I kind of like it. It's a hard conversion and it doesn't work as well when you have operators and stage managers in the US that are sort of used to doing the absolute degrees thing forever. But once we got the hang of it, it's pretty slick. It's hard to know you'll always get you know, if you need to line a very specific thing up on your turntable, it doesn't work as well because you kind of lose things after you know, when everything's relative, it gets hard to know, oh, right now I need to line this track or this seam up, which is kind of why we've always done the absolute degrees thing. But Lauren, I don't know what your thoughts are.
I've done the absolute degrees thing too. It's a little easier to do in your head, you know. I mean, you 360 times 2, it means things going around twice.
Yeah.
But I don't know. I think the kids are having trouble with math these days, and so maybe they need to have, the hands on the clock thing works better for them.
Yeah, it is a sort of strange thing, and lots of systems seem to deal with it a little differently, but it is for us, the challenge has always been when somebody decides to go back, 10 cues in the show and says, oh, I want to move that forward 10
Right.
degrees. Well, does that mean all the cues subsequent are supposed to move 10 degrees, or does that one cue change? A lot of it becomes a communications challenge with
Yeah.
the creative folks sometimes about what they really are asking for.
Mhm.
I was muted, sorry. Chris Babby, I'm just pulling questions now.
Yeah, great.
Mhm.
How do you keep the chain? Whoop, it just jumped. Where'd it go? How do you keep the chain on a sprocket that large? I think he's referring to Lauren, to your UHMW sprocket.
Okay, well, the chain tends to stay on there by itself. Basically, you start at the nether end out there and you have two students grabbing the chain and they pull it around, keeping tension on it until they get it back to the whatever drive unit we're using. And if we need to, we can always slip a zip tie through there and tension it to keep it sort of tight at that point while we're dealing with getting it around the motor and then pulling tension on it. It hasn't been a problem at all.
Yeah, we had a little bit of trouble on our Lion King approach, I think, just because we didn't get the size, we didn't get that sprocket set quite right. And we ended up with a couple little rollers where we needed to. I will say we also have a couple turntables mostly for rehearsal purposes. I don't think we have any in show conditions right now that I can think of. But we've also done some where we've built, some very simple, all plywood turntables with essentially just a plywood trough, and just wrapped a piece of chain right into the plywood trough, no sprocket. And with enough tension, the chain generates enough friction and it makes the machine really easy because you can just, throw a sprocket on a motor like Lauren's picture, and it's real simple. I popped open the chat and I just saw somebody kind of talked about sizing the chain for those machines. Our experience has been that the smaller you can make the chain, the quieter it is. And so we try to keep that chain as small as we can. If you look, the tension ratings on chain are pretty high. And you tend to, if you're around the outside of a turntable, you tend to have a pretty good, mechanical advantage. So there's not usually a lot of line tension unless you're doing something really, really heavy. So we've been using standard number 40 chain for most of those applications where we've done it. But, I think it a little bit just depends on how heavy and how big your turntable is.
Yeah. Hey, Chuck,
Yeah.
just for comparison, bicycle chain is 50.
I think
25.
25. Yeah. So 40 is like a half-inch pin to pin length.
Right.
Right.
Okay.
The first number stands for the number of 1/8 inches
Right.
between the roller pins.
Yeah.
So 40 would be 4/8
All right. Okay.
Right.
half inch.
And I just wanted to mention it, but one of the questions we often get on the sort of friction drive thing that I show was like, well, does it really work? What if it gets really big? What if it gets really heavy? But as example, we did that same basic design for a donut turntable that was the full width of the Park Avenue Armory, which I think is about 125 feet, 130 feet across, Bill, if I'm not mistaken.
Give or take 6 or 8 inches.
Yeah. And we did an I-beam framed 130 foot diameter, 20 foot wide donut in that space that we friction drove with 6 10 horsepower friction machines with, literal sea containers as scenic elements spinning around the room without a problem. So if they tell you friction drive doesn't work for big things, don't believe them.
We did a version of Wojciech with it was a 40-foot rental turntable with a chain wrapped around the outside, number 60 roller chain around the outside, just a friction drive.
Yeah.
But you put 70 opera cast singers on one side of the turntable, and it began to strip the casters of the rubber. And so, and then the caster had failed, so the load would shift to the next caster and so on. And pretty soon it actually broke the connection between the vector motor and its stator. And the thing screamed like it had bad bearings. It works, but wheels have to turn.
Yep, absolutely.
What about getting power to all of that stuff?
Yeah, I mean, yes, if you have to move it, either slip rings or we still on many a Broadway show have holes into trap rooms at center so that cables can get wound up, and somebody has to sort of remind somebody, hey, if you went 10 revolutions one way, you better go 10 revolutions back before too long. But otherwise, yeah, I think like Loren said, slip rings is what we resort to, which again is an expensive and complicated solution, but sometimes it's all you got.
Well, they didn't use those on the Jane Eyre project. For all the expense that they went into that, they didn't have a slip ring on it. It was wind up the cables and unwind the cables. That was another part of the problem, keeping track where things were. Because
yep, we can only go so far.
Yeah, we cut some sound cables and so on. So yeah.
Okay.
Oh, we still have an audience here.
We still have an audience, but I don't have any more questions. I got a comment from Billy Larimore that I like. Chuck, I think maybe you would comment on, and they're talking about counting and TT positioning. Les Mis used 10,000 to the 100,000 count.
Yeah, I mean, my gut tells me that, and that's, I think that probably dates that control system, but I know, and I'm sure we have some folks on here that have dealt with it, but there was a time and a place where the control system sides of things really didn't like to go negative, or you were working with like real, like actual, like processor limits on like the size of the numbers that those pieces of equipment could handle. And so it was not unusual to sort of be stuck in this, we're always going to go from, plus 10 to whatever, or 10,000 to 100, because that was like, you were hitting limits on controllers. That thankfully we seem to have gotten out of with, I don't know anyone system that sort of forces those problems anymore, where you're sort of stuck with a number range that you can't sort of scale or make into what you'd want. But there was certainly a time, even since my time at Hudson, where that was a real problem, where you just, negative numbers was tough with some of the old PLC controllers.
Okay. Folks, we're pushing quarter of, so I'm gonna call it here. I got a couple of quick announcements, but one of our attendees has asked if you guys have any books that you can recommend on the subject.
Creative Connors book, Automation Handbook. Yes, Automation Handbook. Scenic Automation Handbook is one.
Okay.
Got a very famous co-writer. And
Who was the famous co-writer?
moi.
Yeah, okay.
And also Alan Hendrickson's book,
Yeah.
Mechanical Design for the Stage. There it is.
Yeah, that's that one.
Probably those two would be the most important, I think. What do you think, Chuck?
Yeah, no, I think absolutely. I mean, I go to my copy of Mechanical Design for the Stage regularly for both ideas and also just to refresh on the math. But and yeah, no, the Creative Connors book is really well written. So I without a doubt, those are the ones to go for as some really great jumping off points.
Sarah's put the Creative Connors link in the chat, folks, if you're looking.
Okay.
Quick question to Loren from Tom Hackman. Was the hand crank winch the same one published in the Tech Briefs or Tech Expo?
Yes. Yeah.
Okay.
Mhm.
Cool. Well, folks, thank you all very much. A couple of quick announcements here. I want to remind everybody who's ETCP certified, if they want to get credit for this class, they have to notify me by email by Saturday morning, and then I'll turn it in. You still have to keep your logbook current in case they call you up and ask you. We're going to be doing another session coming up. I'm not exactly sure when, so I don't want to guess, but within the next couple of weeks, we're going to do a hemp house session. We're going to do a session on good old hemp houses. Eddie Raymond and I are going to play and try not to hang each other. That's kind of it for now.
So
Oh.
do we bring our own cannabis for that session?
You bring your own. Bring your own. And yes, this is, somebody just asked, this is being recorded. It is still being recorded. Please tell me it's still being recorded. Yes.
It is.
It is good. And Sarah will put it up, yeah, sometime on, midday Friday probably, but it'll be on Friday. Okay, and I'll put an announcement out on Friday morning just to remind you. Chuck and Loren, Sarah, thank you very much for your help and for all the great information. Everybody else, thank you for joining us, and everybody have a good and safe afternoon or evening, whatever the case may be.
Thanks so much, Bill. Thank you for having us.
Thank you, Bill. Good day.
Thank you. Goodbye.
Thank you.
Thank you very much.
Thanks, Bill, for a great session. Thanks, Lauren. Nice to see you again.
Thanks,
You
everybody.
too, Mike.
Thank you so much, Bill. Thank you, Lauren.